This video, the script, the animations, the voiceover, the edit, was made by an AI agent in a single automation run. No human storyboarded a frame. And here's the part that should feel strange. It's about to explain, step by step, exactly how it made itself. Then tomorrow, it'll make another one, a little better. So let's open the machine while it's still running. Start with why this is hard. Make an AI make a video sounds like one task. It isn't. It's research, then a script, then a visual identity, then animation, then a voice, then rendering, then editing, then quality control. 8 crafts. One wrong assumption in any of them, and the whole thing ships broken. You cannot cram that into a single prompt and a single model call. The context is too long, the failure modes too different. Therefore, the first design decision isn't about AI at all. It's about structure. How do you let one agent run an 8-stage assembly line without losing the thread? The answer is the spine of the whole system. You don't hand the agent a pile of tools and say go. You hand it an environment with exactly one rule. There is always a single next step, and you must ask for it. The agent calls one function. What do I do next? And the system replies with the one action that's allowed right now. Pick a voice. Write the script. Fact-check it. Plan the scenes. Build scene 7. The agent does that one thing, then asks again. It is a state machine, and the agent is just walking it. But why bottle the agent like this? Because the failure mode of an unconstrained agent is confident drift. It'll skip the fact check, or declare a scene done it never rendered, or quietly start step 9 while step 4 is still broken. The state machine makes that impossible. Each step is also idempotent. Ask twice, get the same answer. It never advances on its own. The agent literally cannot run ahead of the work. Freedom inside each step. Zero freedom to skip one. There's a lock under the hood that enforces it. Every time the system hands out a step, it mints a short token. A one-time key for that exact stage. And every tool that changes something, save the script, store a scene, start the render, refuses to run without the current key. So the agent can't reach back and redo a finished stage, and it can't jump to a future one. The token is the proof that you're acting on the step the system actually gave you. Coordination enforced in code, not in good intentions. Now the part that decides whether the video looks like anything. Every scene is not a clip, it's a web page. A self-contained page with a single animation timeline built live by the agent. Charts that draw themselves, text that flies in on the beat, a diagram that assembles piece by piece. All of it is code, authored on the spot for this one scene, which sounds elegant, but it hides the single most important constraint in the entire system. And to see it, you have to know how these scenes actually get filmed. Here's the thing nobody expects. The renderer never plays the video. It jumps. Frame 800, screenshot. Frame 801, screenshot. It seeks to a moment in time, freezes everything, and photographs it thousands of times, cold. Therefore, every scene has to be a pure function of time. At second 12.4, the scene must look exactly one way, no matter what came before, no matter what the last frame was doing. which bans something most animation quietly relies on: randomness. The instant a scene calls for a random number or reads the wall clock, it's dead. Because on a cold seek, random gives a different answer every photograph, and your steady star field turns into TV static, one frame to the next. So the rule is absolute. No randomness, no clock, no where was I. If you want 100 drifting particles, you seed them from the timeline itself. So frame 800 is identical whether you arrive from frame 1 or frame 799. The whole scene has to be reproducible from a single number, the current time. Get it wrong, and it passes every preview, then strobes in the final render. That timing has to come from somewhere true. So before a single pixel is animated, the system renders the narration. The voice for the scene is generated first, and it hands back the exact second each line begins. Only then does the agent animate, pinning every reveal to a real timestamp from the real audio. The picture follows the voice, never the other way around. The words land, and the chart draws itself on the word, because the chart was told when the word arrives. But an agent authoring code it can't see is an agent shipping bugs it can't see. So before the expensive render ever runs, a headless browser opens the scene and inspects it like a ruthless reviewer. Is text spilling off the canvas? Is a font too small to read on a phone? Is something animating a blur, which would melt the render? Is a system font in there that will hard fail the final stitch? Around 18 separate classes of bug, caught at the source, for pennies, instead of after a multi-minute render, for real money. Fail cheap, fail early, fail before the farm. Then the farm. Every approved scene is shipped to its own cloud worker and filmed in parallel, 24 scenes. Don't render one after another, they render all at once. So the wall clock cost of the whole video is roughly the slowest single scene, not the sum of all of them. Each worker is a headless browser, doing that cold seek dance, frame by frame, and handing back a finished clip. Last, the edit. The clips are stitched in order, transitions laid across the seams, and the background music tucked underneath. Automatically ducked by a compressor that hears the narration and pulls the music down every time the voice speaks, then lets it swell back in the gaps. What comes out is one file, a complete, narrated, scored explainer, and not one human touched the timeline. Step back and look at what that architecture buys. Determinism, plus a state machine, plus self-QA before every render. Together, they let one agent run a 24-step, 40-minute pipeline without a human babysitting each move. The human isn't in the weeds. The human stands at the gates. Approve the script. Approve the script. Approve the look. Approve the final cut, while the machine does the 1,000 small things in between. That's the whole design goal. Not automation that replaces judgment. Automation that saves it for where it matters. Except, and this is where the war stories live, it doesn't always work the first time. The nastiest class of bug in this entire system has a name. The preview lies. A scene looks flawless in the live preview. It passes every quality check. Every still frame looks perfect. Then it renders on the farm. and the text is in the wrong place. Because the thing that draws the preview and the thing that films the final are two different engines, and every place they secretly disagree is a bug you cannot see until the render is done. Making this very video, a single duplicated line of styling shifted a whole block of text, invisible everywhere except the final cut. And the Seek renderer hides a whole museum of these. Animate a blur, and because every frame is redrawn cold, 1 minute of video tries to render for 20 and times out. Slowly zoom a photograph, and a single frame catches it mid-paint and flashes black. A gently looping pulse, evaluated on a cold seek, pops one frame out of place. Download a stock clip with sparse keyframes, and the renderer freezes solid trying to seek into it. Use the wrong font, and the final stitch hard fails after the render you already paid for. None of these show up in testing. All of them ship to the final file. Each one, the first time it drew blood, was a mystery that ate an afternoon. So, here's the part that makes this more than an assembly line. When the video is done, it doesn't just ship. It stops at one last gate, a retrospective. And two things get written there. First, a human watches the cut and leaves a small dose of taste, a rating, and a sentence about what felt off. Scene 7 drags. That title's hard to read. Second, the agent writes its own honest post-mortem. What broke, what it wasted time on, and a concrete list of fixes. Not to the video, to the machine itself. One gate, two kinds of feedback. One about the thing it made, one about how it makes things. Because that second list is where the system grows up. A separate agent running in the background picks up those fixes and implements them as real code, committed, deployed. A new check that blocks the duplicated style bug. A rule that refuses the blur. A guard against the bad font. Every scar from the last section becomes a guardrail in the next run. The harness writes its own bug reports and then patches itself. While making this very video, it hit a real render failure, diagnosed it, fixed the code, and recomposed. That fix is now permanent. The next video can't trip on it. And none of this waits for someone to press go. It runs on a clock. Every day, on its own, the system wakes up, picks a topic, and produces a complete video, start to finish, unattended. Overnight, the background agent drains the retrospective queue and improves the harness. So the machine isn't just making videos, it's making videos and getting better at making videos on a daily cadence while no one's watching. You come back in the morning to a finished cut and a harness that's a little sharper than it was yesterday, which is the real distinction worth sitting with. Almost everything here is autonomous. The research, the writing, the animation, the rendering, the bug fixing, the scheduling. The human supplies one thing and only one thing: taste. And it shows up on exactly two dials. One, is the video any good? Is it clear? Is it beautiful? Does it land? Two, is the machine improving in the right direction? Which fixes matter? Which rules to keep? A small, deliberate amount of human judgment, pointed at the two questions a machine genuinely can't answer for itself. Everything else compounds on its own, which points at something bigger than video. The model at the center of this will keep getting smarter every few months. That's not the interesting part. The interesting part is the harness, the accumulated wisdom around the model, the gates that catch drift. The 100 lint rules, each one a memory of a specific failure. The model is rented. You swap in a better one every few months. The harness is owned. It's the part that compounds. We spent years asking how to make the model better. The quieter question is how to build the workshop around it, and how to let that workshop improve itself. So look at what you just watched. The script, the visuals, the voice, the edit. One run through the machine I just described to you. It even hit one of those render bugs along the way, caught it, fixed itself, and kept going. Tomorrow it'll do it again. A little better, because tonight it patched itself. The future of AI agents was never going to be one giant brain that knows everything. It's a workshop that gets a little wiser every time it breaks. And the most interesting thing this workshop builds is itself.